Welcome to our next analysis. Today we're looking at something that probably troubles every driver. Road reconstruction. Those endless preparations, restrictions. We all know it.
Exactly. It often seems like the preparation takes more time than the actual work on the road.
Precisely. And that's why today we're focusing on one, I think, very interesting pilot project. It's about the reconstruction of Road and Brog. There, the Technical Administration of Roads, TSK, tried something new with a technology supplier, Exact Control System, and a construction company. The ExactStreet On Site procedure, or ESOS for short.
Yes, the goal now will be to look at how it all actually works and, most importantly, what benefits it brings. It's supposed to significantly speed up those preparatory phases. We have an evaluation report directly from that project, so let's get to it.
Tato stavba byla komplikovaná z důvodu omezení při hloubce frézování, kdy se narazilo na původní dlážděnou vozovku. ExactStreet On Site nám umožnil obratem reagovat na tyto podmínky s okamžitou úpravou modelů, kdy jsme byli schopni dodržet zasmluvněný termín i čas realizaci.
Right, so in short, ESOS is a method to repair the road surface but smartly. It uses a 3D optimized design that is created, and this is important, directly on the construction site, on site, automatically by the milling machine itself, which in this technology not only mills the road, but also measures and draws all the critical lines for 3D design.
Right on the spot.
Exactly. The goal is not only a precise repair so the road lasts longer, but most importantly, as you said, to speed up the entire process from idea to a finished road.
Without the lengthy and dangerous surveying by engineers on the road, and without endless design work in the office.
Exactly, and not only that, most importantly, it eliminates the need for separate tenders for those tasks, which can reduce the entire project timeline from years of preparation to a single short tender for milling with integrated on-site measuring and modeling functionality.
You're saying just one short tender? That's amazing.
Yes, in Prague, TSK issued the tender, and within a month, the milling had already begun, and everything turned out great.
Z pohledu zakázek je to také jednodušší, protože jsme schopni soutěžit frézování z 3D a nemusíme se věnovat tolik projektové přípravě. Ta rychlost nám umožňuje vlastně, a to je to, kde vidíme ten největší potenciál, částečně přeskočit tu projektovou přípravu, ušetřit na ní a věnovat co nejvíc energie tomu opravdu důležitému, a to je příprava kvalitního povrchu pro samotnou pokládku.
And the main innovation, what makes it different? Because I think this is where it starts to get really interesting.
The key thing is this. Imagine the usual road milling machine. During the first milling pass, when it removes the top layer of asphalt, it doesn't just mill, it also measures simultaneously.
Precisely, at the same time using GPS sensors along with special algorithms to refine the measured data to millimeter level accuracy.
So the milling machine acts like a surveyor. That changes everything, doesn't it? The whole classic terrain surveying is eliminated.
Essentially, yes, that's phase one, data collection. The milling machine mills the first layer, let's say to a constant depth of, for example, 4 centimeters, and the ESOS system records its precise 3D position and slopes at every moment.
And what about that data?
That data is immediately sent to the system's cloud server called ExactOptiMill.
And then comes phase 2, the on-site automation.
Yes, on that server, a digital terrain model of the milled surface is automatically created from the milling machine's data. And right after that, based on specified parameters.
Like what slope should be there for water drainage, how even it needs to be.
Exactly. Slopes, evenness, how it connects to sidewalks, drains. Based on all this, the server calculates an optimal 3D model for the final repair. We call this ExactOptiMill design.
So the server is basically a super fast designer that works with data directly from the milling machine. That's fascinating. This means the classic project documentation, RDS or BIM models, which are usually done separately, are no longer needed.
Precisely. The need for separate design work is eliminated, and importantly, so are the tender processes for a designer. This saves an incredible amount of time.
And what's next, phase 3?
Yes. Then, a so-called 3D differential model is created. This is basically a simple guide for the milling machine. It shows the differences between what has actually been milled and the ideal design. It simply says mill more here, mill less there, to achieve the optimal shape.
So it's basically telling the machine what to do to get the right shape.
Yes. This model is sent back to the milling machine, and then, using that precise GNSS guidance, it makes a second pass, milling the second layer, but this time with variable depth, precisely according to that calculated model.
Is there any check, or does it run completely automatically?
There is an option for a check. The calculated model can of course be reviewed and approved by a specialist like a design engineer or a surveyor before the second milling pass.
Let's talk about the benefits. We've already mentioned the huge reduction in preparation time. Tenders for surveying and design are eliminated. Documents are ready in hours instead of weeks. What else?
Another big plus is the precise geometry, better drainage, better riding comfort, and according to TSK data, based on their experience, such precision can extend the road's lifespan by up to 50%.
Co mě na téhle technologii baví nejvíc, je, že dává ekonomický smysl. My investujeme nějaké 1% nákladů stavby na to, abychom prodloužili životnost komunikace o 30 až 50%. A to je rozhodně deal, který stojí za to.
When you mill precisely, then you only use as much new asphalt as is truly necessary. Estimates talk about savings from 5 to 50%.
Wow.
And we mustn't forget the environmental aspect. It also allows for selective milling, meaning that you can separate just the top layer, for instance, for better recycling.
Nespornou výhodou 3D frézování je i ekologická šetrnost. My vlastně odvážíme mnohem menší množství materiálu z té stavby. I ten materiál dále používáme pro recyklaci, ale i toto nám výrazně zlevňuje tu stavbu.
But what about the role of people? Does this mean the end of surveyors or designers in this field?
I don't think it's the end, more like a transformation of roles. Collaboration among everyone is key. The client, like TSK, says what they want. The contractor, in this case it was Strabag, does the work and now also handles the surveying with the milling machine and the model creation.
And the technology supplier.
They provide the system and support. And the surveyor, they still have an important role, but more of a control and validation one. They verify settings, can adjust parameters, and ensure RTK corrections for maximum precision.
RTK corrections, those are the signals that pinpoint location to centimeters.
Yes. And, of course, we mustn't forget the milling machine operator. They must be well trained to collect data and then also to mill in 3D.
And how did it turn out specifically in Prague? Do we have any numbers from the report?
Yes, we do, and they are very positive. For example, the International Roughness Index, IRI, which measures how smooth the road is, improved from an average of 4.5 meters per kilometer before the repair to just 0.6 after.
That's a huge leap in quality.
Exactly. You notice it in riding comfort immediately. And the cross slopes were also significantly improved and unified.
Less time in preparation, longer lasting roads, and smoother rides. That sounds like a win-win.
It is, and this project clearly demonstrated what's possible when real-time data collection and automated 3D design are fully integrated on site during the actual resurfacing. The key innovation is that all the complex processing happens off-board on the cloud server. The milling machine just needs a control computer and access to the ExactOptimill server. And here's the exciting part. This feature can be adopted immediately by all major road milling machine manufacturers. It's essentially a software-level enhancement to existing hardware.
So this could unlock an entirely new market for the milling equipment industry.
Absolutely. It opens the door to next-generation road resurfacing, more efficient, more sustainable, and fully digital.
That makes it globally scalable.
Exactly. It's not just a local innovation. It can be used almost anywhere. In fact, the European Union already supports methods like selective milling, which improve recycling and reduce environmental impact. This technology aligns perfectly with those goals.
Yes, and there's more. The technology is being developed with financial support from the European Space Agency, which is Europe's equivalent of NASA. That kind of backing is a strong signal. It's not just a good idea. It's a serious, high-integrity technology recognized by one of the world's leading scientific authorities. If ESA believes in the concept, it speaks volumes about the quality and potential of the platform. And how often do you see that? ESOS is more than just a tool. It's a platform that could redefine how the world thinks about road resurfacing.